Hi guys, welcome to Learning Electronics Repair, and look what's on my bench today. Yeah, all this lot. So this is how this actually arrived. Oh, plus that one as well came with it. This is from a guy on the island of Gran Canaria. He actually lives up in the interior in one of the more mountainous areas, and he brought me these PCBs. So this basically is a television, a CRT television. It's from a Mitsubishi. He said I think it was 37 inch or something like that. So this is a very large CRT television. I thought the largest they made in 4:3 ratio at least, which I think this is, but I'm not sure, was about 28 inch, yeah, and then 32s or so in the widescreen ones before everything eventually went to the flat panels we have now. But anyway, this is from an old television, and this guy, who's not a particularly old guy by the way, a lot younger than me, collects them. He collects CRT TVs. There's a first person I ever really came across that collects them, but there you go. I asked him why, and he said, well, because I'm a geek. Yeah, I mean, you can't argue with that. So anyway, here's your TV on my bench. Now, why do I just have a pile of PCBs here? Well, the television weighs about 90 kilos, and I can't actually fit it on my bench. That's the other reason. Yeah, I don't have the space to work on equipment that large. And he also said it would be a big problem to transport it. He said, well, can I bring you the circuit boards in? And the conversation went, well, what's wrong with it, I asked. And he described the problem. I know what this problem is. So he says that when he has a bright picture or a picture with a lot of white background, the picture is like wiggly like this down the edges, yeah? This sort of effect. Or a bit more rougher than that. But if he has like more of a single colour picture or background or dark background, it doesn't do it. And this is called line tearing. So if you ever, for any reason, have to work on this sort of equipment, this is called line tearing. Line tearing, okay? And what basically causes it is, well, I'll have to put this on a piece of paper, won't I, for those of you who don't know much about television. A picture paints 1,000 words, and a video probably paints more. So here's a short video. This is line tearing. So you can see that the line scanner started at the wrong time. Look, the screen went black. It doesn't do it. It went back to a bright colour. It did it again. And you can see it's happening where there is actually different coloured areas on the screen. You see that? So it's where there's text or there's a different colour in the background. Look, you see it there, okay? So that's what line tearing actually looks like. So what causes this? Well, it's basically the way the TV processes the video signal, or composite video, which contains both the monochrome image and the colour information. And it also contains line sync or synchronization pulses and frame sync pulses. So basically with these old TVs, you have a scanning across the screen, a line at a time, and after it scans each line, the position of the line drops down slightly, it scans again. So you get like a whole row of lines like this across the screen. And each line then you can vary the brightness and the colour information across the line and draw one line of the image, and you keep doing that down the screen. And if you do it fast enough, then to the human eye, it looks like an image and not like a load of lines flickering everywhere, yeah? Okay. And to do this, the scan of the line has to start at the right place, the start of the line. And the frame, that's the lines from the first line to the last line, has to start in the right place. Otherwise, you get a vertical rolling or movement, or you would get a horizontal movement, okay? If the timing was out, if you were starting the lines or the frame, yeah, at the wrong time. So with CRT TV, this is an analog system, okay? And the video information is called composite video, as I mentioned. And this is what it looks like. So we have this, if you like, as the white level. This is the top of the signal, and this is about 1 volt high, okay? And obviously the bottom of the signal is 0 volts, okay? But the black level we'll put it here, is 0.3 volts. Okay, so anything below 0.3, the colour is black, yeah. And from here upwards to 1 volt is your video information. Yes, it contains colour information as well. It's not relevant for this discussion, so we won't worry about it right now. So the way the composite video signal is made up, composite video, okay, is we start with the sync pulse, a line sync pulse, okay, which goes down towards 0 volts from the 0.3, and then here is our video information, yeah, different colours of brightness, and then we come to the end of the line and we have another line sync pulse, and then more, we have, you know, video information, yeah, and so on. And then at the end of the last line of the screen, which I'm going to have to put here because I've written there, yeah, we have a frame sync pulse, which is like a line sync pulse, it's just wider. Okay, so that's what's contained in the composite video signal. And what causes a line tearing, you can see on that video I found of it, is that the line oscillator, effectively this generates a sawtooth wave. Let's put it on here, so this is your line sync pulse. It's better if I look at the paper and not the screen, yeah. Sawtooth wave. There's your sync pulse, but this generates a sawtooth, which I have kind of out of scale, so we go again. Sawtooth wave, there's the line sync pulse. Okay, that's how it actually does it effectively. Okay, now the sawtooth wave is supposed to start where the sync pulse is, but what's happening on that picture, you can see where there was some video information, it was kind of tearing and starting at the wrong time, and that's because the line oscillator, or the synchronizing circuit, is mistaking part of the video information for the sync pulse. Yeah, it's mistaking it, and there could be a few reasons for that. So first reason is that there's a problem with the composite video signal itself, which is generated by effectively the receiving part of the TV. Receives the television signal, divides it into luminance, or black and white, into colour, which on a sub carrier, but we won't go into that now, into sound, yeah, which on another sub carrier, but we won't go into that now, line sync pulses and frame sync pulses. So the circuit divides the signal into all those things, and there can be a problem in there. Okay, more commonly there can be a problem with the actual line oscillator, the sync circuit, and often if there's a problem there, it's due to bad capacitors, old capacitors, yeah. And the other reason for this is there could be a problem with the HT generation. This is the high voltage, 25,000 volts. I think on this TV is more like 35,000 volts, which is generated by the line output transformer. Okay, and problems in that circuit can also cause the HT voltage to fluctuate with the video signal, and that can cause a line tearing as well. Okay, so that's the basic causes of the problem. How to go about this repair? Well, first of all, I said to the guy who brought this in, I don't think I can fix this. I haven't got the TV, I've got the circuit boards, I don't have any way to really easily diagnose what's going on with it. But what I will do, I will ask some of the guys on the live stream, because I know some of the guys are into TV on there. Okay, so a few weeks ago I asked on the live stream, I told them, I showed the guys, these are the circuit boards, what do you think? And some of the guys watching the live stream were fairly familiar with these TVs, so these are apparently rather collectible and therefore fetch a high price, have a high value, because there are collectors for them. And they have some known issues, and one of the known issues in particular is this line tearing. So if we just look here, you'll see a big transformer, this thing. Okay, this is the line output transformer. So this is doing two things. One, it is energizing magnetic coils around the CRT, the tube, yeah, magnetic coils, which cause the beam to scan vertically and horizontally. So this drives those coils, and that's what moves the spot across the screen and the lines as it scans down. Okay, another thing this is doing, because it's running at line frequency, which is 15.625 kilohertz for 50 hertz mains, EU or UK TV, because it's running that frequency, this also has an overwinding on, which generates the very high voltage needed for the CRT, the final anode. This is the 25,000 or more volt thing that fits on the front of the tube. Okay, as well as doing that, by the way, in some sets, and quite possibly this one, because this is effectively like a switch mode power supply type thing, it also generates some of the voltage the thing actually needs to run on. So it has a startup circuit. Once it gets going, this generates auxiliary voltages which power the setup, like some switch modes that you see in repair with the aux winding, yeah, but with more aux windings. So that's effectively doing all that. And normally that goes to a voltage doubler or tripler, which is basically made up of a sequence of high voltage diodes and high voltage capacitors that step the voltage up to the CRT. But because this is such a big CRT, we have this thing attached. So this is a voltage doubler or more. You can see high voltage into here. This generates your focus voltage for the tube. That's this thing. And then it goes into another one. And then this generates the very high voltage for that. Okay, and the known problem with this is that these fail, and the failure in this, or one of the common failures, causes line tearing. So the consensus of opinion was that you've got a problem in this because it's a known issue with these. The symptoms exactly fit that known issue and you can't get them. Okay, so can't repair. That was the basic diagnosis, yeah, from the guys watching, and I can agree with that. So they said the only way you can get these things off the scrap one, if you can find the scrap one, and if the scrap one can't be repaired anyway because, well, they're quite valuable bits of kit, maybe something with a broken tube or something, that's the only way you're going to find one of those. That's what they said, and I thought that would be the end of it, really. Can't fix it, almost certainly that. The owner then came back to me and said, well, how about repairing the other possibility? And the other main one I thought was a problem around the line oscillator. So this is the line oscillator chip. I'll show you what it is in a minute. And there's some capacitors around here. It's possible we have bad capacitors in that circuit causing this problem, but it's just one of those possibilities. Without being able to power this up, there's no real way to be able to prove that, which I also explained to the owner. And I said, well, yeah, I can, but you know, I have no idea whether or not it would make any difference. It quite probably won't make any difference. But he said, well, you're my last hope. Thanks. So do it and I'll pay you. Okay, so that's where I am with this. Change the capacitors around here and you'll pay me. Personally, I did advise against this, but you guys can talk about it. I chatted with the customer, and that's where we're up to. So this is the actual chip, TDA 2579A. Now, you might think the chip could be faulty, and although I suppose you couldn't 100% actually really eliminate that possibility, they don't tend to fail, at least not in that way. So if these things do fail, they don't oscillate. They don't really fail in this instance. It looks a little bit discoloured. I mean, we can try and clean it up, but that's the line oscillator chip. And then we have some capacitors around here, which, I mean, these were as old as a TV, and this area gets quite warm. Horizontal hold, horizontal phase loop, service, whatever that means. So 1, 2, 3, 4 old capacitors there. There are a few more in this area, a couple of smaller ones, a couple of bigger ones, and then a few more back in this part of the board. I see 3 more electrolytics. So under the instructions of the owner, I'm going to change all these capacitors. He's going to pay me to do that, and then we will see. And I'll have to let you guys know. Oh, maybe one or two more hidden, yes, down there maybe. Okay, so let's have a look what we have, and let's do what the customer asked. Yeah, can't do more than that. There are different ways to go about this. I mean, we can get a couple of photos of the thing, but this won't really tell us what value is what because we can't really read them. My preferred method, but this is just methodology, it's nothing to do with the repair as such, is to unsolder them all, one at a time, draw a little picture and write all the values on, and then once I've got all the capacitors off, see if I've got all the ones I need, and we stick it back together. If I have to order some, I have to order some. So I'll just start along here. So we'll take each one off, and we'll just make a note to see what it is. They're marked at least with the negative end, I can see that, so I don't have to worry about making a note of the polarities. That's actually marked on the silk screen into the green blob being the negative. There are different ways we could go about this. We could use the vacuum desoldering tool, we could use braid. We'll probably find that all the legs are actually bent over on these capacitors. I'm probably going to use this technique, which is just to effectively warm up each end and just gently leave the components out, and then afterwards I'll clean the holes. I find this generally the easiest way to do this sort of thing. One is in the way of the other here, so I'll just remove the other one first. So just find out where it actually is. Okay, first one out. So this is a 22 microfarad 16 volt. You could test these and put them back in if they test okay, but because it is possible that the thing gets warm, doesn't work properly, or for any other reason, and the customer asked me to replace these, I'm going to replace them. Okay, and as I go along, I'm going to draw a little picture. So this is the line oscillator chip. I can draw where the capacitors are, so there's two in front of here, there's another one here, the one I unsoldered. These are the potentiometers, so I can just kind of mark them, I know where they are. Okay, I have some more back up, so there's a heat sink. So this one I'm just making a diagram really. There's two transistors on there, there's a capacitor here, there's a bigger one here and a bigger one here. Then we have two more here, we have two more there, and then we have a big one and another big one. So that's where they are, and what I can do now is I can just mark the values of each one as I go along. You could probably do this by taking photos, but maybe not as easy as you might think, or maybe you wouldn't think it was easy. Okay, so that one, 22 microfarad, 16 volts, and I'm just going to work my way across. So let me see what I can find on here. I've just unsoldered this one that fits here, and this has been changed before. You can see some of these being working here. It looks like this IC has been changed before, and we have this red wire from here down to the line oscillator, and I suspect that might also have been changed before. So it's possible somebody has already tried to repair this fault. Anyway, I understand, and then hopefully you'll post on here that you bought this second hand off somebody. It was supposed to be working, but when you got it, it had this fault. Is that correct? Because somebody, I think, has worked in this area of the circuit before, possibly trying to repair the same defect. And while on that topic, this one has been changed, or at least desoldered. I mean, I don't think they've been changed, but they've been removed for certain. And there's two units here. So one is a tuner, and then something else next to it. Okay, like a big metal can. and that one has also been changed, and I would say probably this one as well. So somebody's definitely been through this area of the circuit on this. Yeah, working. Similar something down here as well. This area, this is part of the power supply. Okay, maybe just soldering bad joints, but whatever, this is definitely being worked on previously, and maybe that red wire is being fitted to repair a track that they broke. Okay, so there's the diagram. I've removed 13 capacitors, unlucky for some maybe, but ignoring the superstitions here. All these capacitors were marked 85C apart from this one and this one, which are marked 105C. Normally speaking, they could well be low ESR capacitors. The 85C ones, in my experience, are not low ESR. Let's just have a look at them. Let's see if any of them are actually bad. But I'm going to replace all of them anyway, as the customer asked. So because there's only 2 which are likely to be low ESR, I'll just test all the other ones for capacitance. What do we have? Let's start with these big ones. So Nichicon 1000 microfarad, 35 volts, 105C. So we'll check the ESR as well on this one. I mean, it's not far off 1000. I mean, these things are never very close tolerance anyway. Very low. Another one, 1035. Nichicon again, 105C. Yeah, how's this one read? We'll go ESR first. On this one, very similar to the other one, and we don't need this now. Yeah, close. Right, this one, 47 microfarad high voltage capacitor. That actually reads, let's see. Well, that actually reads bad. There can't be any charges. I mean, this thing hasn't been switched on for a long time, yeah. A couple of months at least, I would have thought. Short it, you never know. Go again. Well, looks like you might have a bad capacitor there. You might be lucky. Read it the other way around because the polarity doesn't really matter with a capacitance meter. No, that reads bad. 470/35. Again, a bit lower, but not a lot lower really. This one, 1050. No, 150, that's what it's reading as well. Yeah, close enough. $125. Down the range. Close. $10.25. $33.16. It's 34. 1 microfarad. 50 volt. Yep, close enough. $2.2. 50 volt again. 2.2. Fine. 22, 16 volt, fine. This one's a 1 microfarad. Yep, reads 1. And this is the last one, which is 4.7. Reads about 4.5. Okay. So maybe we do actually have a faulty capacitor here. It's a bit unusual for these high voltage capacitors to fail like that. Let's have a look. Yeah, bit of gunge on it. I mean, that could be a bit of glue or something from underneath. Can't really say. Let's just check this one again. No, now it reads okay. So we weren't so lucky after all. Let me see what I've got on the way of replacements. Guys, this is what I have and what I don't have. So these are the original values. Some I have substituted, so the 1 microfarad 50s, I've got 63 volt version, same value, that's fine. Okay, 4.7 microfarad 50, again a 63 volt. These are all 85C capacitors. 2.250, I don't have any of those or anything like that, so I'll order. I may have some poles, but I'm going to put all new parts in this. Okay, 10 microfarad 25s, I've got 1050, that's fine in this sort of circuit. No reason why you can't replace them with a higher voltage. 2216, 2250, fine. 3316s I have. The 47 microfarad 250 volts. I do have 400 volts. These are poles, but let's put new ones in, so I'll order those. 100 microfarad 25s I have. 105 degree C, 100 microfarad 50. I have 105C, 100 microfarad 63. We'll just check the ESR on those. 470 35s I have. Now these ones, 1000 microfarad 35 I have, but these ones. Okay, right voltage, right capacitance, very low ESR, but they're not marked either 85C or 105, so I tried a few different searches, but this is the one that worked for me. 037 series here, Philips 037, and it tells us they are particularly for use in SMPS, switch mode power supplies, so they will be low ESR. But if we look further down here, we'll see these are 85C operating temperature, and the ones I took out were 105. So although they're low ESR and the right value, I'm not going to use them, so I will order those as well. And the other low ESR ones are the 100 microfarad 63, which is that one. This one is marked 105C. Let's just check the ESR. Extremely low. I mean, very, very, very low. Okay, so low you might think it's a short circuit capacitor. We can soon prove that, of course. It's fine. So we need to order those ones, that one, and that one. This is the data sheet for the TDA 2579. So you see horizontal virtual synchronization circuit from 1990. And this, you can see, basically performs the activities that I mentioned. Okay, what does it do? It tells you here. Black level detector, noise level detector, phase detector. So this obviously could cause this type of fault, or problems in this circuit, not necessarily the chip, could cause this type of fault. Okay guys, so that's what we have. We know what to order. I often say you'll see this again, but this one you won't see again because I don't have the TV anyway. All I can do now is replace the capacitors as the customer asked me in that entire part of the circuit, and either it fixes it or it don't fix it. Yeah, From what I can see, there's nothing wrong with the capacitors, but that was my original opinion, so nothing has changed much there. So you can chat about it down there. This is another example. Customer asks you to do something, you do it and you charge for it. Okay, hope you enjoyed that, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.